In this video, you want to go over the method walking on the crossing in order to compute the bracket polynomial. So what we'll do is we're just going to first recompute the bracket polynomial for the unknown that we've seen before, and then we're going to do it for the bottom unknown here. And see, they're very similar, just like one time the crossing is that this strain is over this one, and in the other, it's the other way around. And you will see that walking on the crossing here kind of works better than this just general rule where you cross the crossing horizontally and vertically. So let's go the one that we've already know, just to do it again. So what we'll do, we go along the top strain here. And before the A, we want to turn to the left. Okay. Let me go along with a pointer. So we go along the top strain and then we turn to the left. And we get this knot here, this unknot. And then we're left with this one over here. So here we get A times the picture we just drawn. And then the second part here, we're going to turn to the right in order to get B. So also let me go along with the pointer. We're going to go along the top strain, turn to the right. We're going to get this picture here. So here plus B times this picture. Okay, so before I move on to the second example, let me just show you that it doesn't matter which way I'm walking. Yeah, let's say I was going from the bottom here and I turned left and I get this picture. Let's assume we're going to walk the other way. We're going to walk on the top strain, but we're coming from the top. Okay, now, well, we still want to turn left. So we're going to turn left like this, and we're going to end up with the same picture as for A, as you can see here. Let's do the same for B. Let's go from the top strain here. Now we want to turn to the right. That means we have to go along here. And we're going to end up with this picture, which again is the same as the one over here. So in this case, it really doesn't matter if you go one way or the other. So this is something we've already seen. Let's go to the second example here. Okay, so we're going to go along the top strain here. Let's say from this side. And first, in order to get A, well, we want to turn to the left. And so in this case, we're going to get this picture over here. And you'll see that now, well, it's different than what you would have expected from the original definition. So if the crossing is the other way around, you really get different pictures. So I feel like this is somewhat the better idea going with along the top strain, because you don't have to first put your crossing into the right direction. So you get this here. And then for B, you turn to the right. So let's go along with a pointer. You go along the top strain, you turn to the right, and then you end up with these two pictures. Plus B times this. And before I end, let me also on this picture show you that it doesn't matter which way I'm walking. So if I come from the top, okay, now for A, I want to turn to the left. So I have to turn to the left here and go along. You can see that that here is the same picture as the one you get over here. And for B, if you come from the top, and you turn to the right, you get these two circles. Again, that's the same as over here.